everyone, welcome to our lesson on analyzing map projections, which could also be called math maps and misrepresentation. So we're going to start by examining several countries in different parts of the world to see how the standard classroom map called the Mercator Map treats area and visual representations of those areas. So to answer this question, you'll want to look at countries at the same latitude as well as those in different latitudes. So here is the Mercator map. This map should look familiar to you. It's hanging in most classrooms in the United States. And we will be using the country of Mexico as our standard unit of measure. And a quick Google search has told me that Mexico is approximately 760,000 square miles. Now here is our second map, Map B, which is the Mercator map with a grid overlaid on top. And so what I want you to do is take a minute, there's Mexico again. I want you to count the number of squares that you think cover the country of Mexico. Okay, so when I did this count, I thought that Mexico was approximately 2.5 squares. You may have come up with a number a little bit smaller or a little bit bigger, but I thought it was about 2.5 squares. So our main unit conversion for this part of the lesson is going to be that 760,000 square miles is going to be equivalent to about 2.5 squares. Okay, so let's now find two countries that seem to be around the same size as Mexico, but where one of those countries is roughly the same latitude and the other is at a much different latitude. Just as a reminder, latitude is our moving across the page, our horizontal. So see if you can find a country roughly the same size as Mexico at about the same latitude, and then another that is at a much different latitude. So I decided to pick the countries of Libya and Finland. Libya and Finland. All right, so we're going to go back to our gridded map. All right, find Libya and Finland here. And we'll start with Libya. Count the number of squares that you think cover the country of Libya. So I thought Libya was about 2.5 squares, the same as Mexico. And so therefore I'm going to estimate that Libya is also approximately 760,000 square miles. Okay, how about Finland? How many squares do you think covers the country of Finland? Okay, so I thought Finland was a little bit smaller, but not by much. I'm going to estimate Finland is about 2.3 squares. And now we're going to use our unit conversion, okay? So we're going to take our 2.3 squares, we're going to multiply on the top by our 760,000 square miles divided by our 2.5 squares. Now, therefore, our unit of squares is going to cancel out. We'll be left with the unit of square miles. A quick calculation tells us then that we estimate that Finland is about 699,200 square miles. Okay, so let's analyze this. So here are our estimated areas for Mexico, Libya, and Finland. We can do a quick Google search to find the actual area of these countries and then subtract to see how well we did. So Mexico, that was our starting point. So we're pretty close, right? A difference of just about 1,600. Libya, we're off by about 80,000, not too bad. Finland, however, we're off by a considerable amount, almost 570,000 square miles. So keep in mind, remember, Libya, the one that we were closest in our difference, was that country that was about the same latitude. Finland, the one where our estimate is off by a considerable amount, was at a much different latitude. Okay, so now it's your turn. So what I want you to use that map B, that gridded Mercator map, to estimate the following regions on that Mercator map. So the state of Alaska, the country of Greenland, the continent of Africa, India, and then Scandinavia, which is made up of Sweden, Norway, and Finland. So just how we did this before. So for Alaska, for example, you'll look at that map B, count the number of squares that you think cover the state of Alaska. When I did this, I thought Alaska was about 8.5 squares. And then use our unit conversion, which is that 760,000 square miles represents about 2.5 squares. And so therefore we would estimate that Alaska is about 2.5 million square miles. That would be our estimated area for Alaska. And once you have all of your estimated areas, do a quick Google search to find the actual area and then subtract to find the difference and see which of these regions are you pretty close on your estimate and which ones are you way off. Okay, so you should pause the video and complete problems 1 and 2 of the project handout if you haven't already done so. All right, assuming you've completed problems 1 and 2, here we move on to the next step. Now here is map C, which is called the Peters projection map. And so notice it looks quite different than that Mercator map. And what we're going to do is we're going to repeat this activity with the Peters projection map to compare our results. So again, we're going to be using Mexico as our standard unit of measure. There's Mexico on the Peters projection map. Mexico is still in real life about 760,000 square miles. Now here is map D, the Peters projection map with a grid over top. Now on this map, about how many squares do you think cover the country of Mexico? So here I estimated that Mexico was about 3 squares. And so with the Peters projection map, our unit conversion is going to be that 3 squares represents about 760,000 square miles. Okay, so now it's your turn again. So you're going to use map D, the gridded Peters projection map, to estimate those same regions. This time it's going to be the exact same process except using our new conversion, which is that 760,000 square miles represents 3 squares. So for example, on Alaska, on the Peters projection map, I estimate that Alaska is about 2.5 squares. And so when we multiply by our unit conversion, 760,000 square miles is 3 squares. Then now I estimate the size of Alaska to be about 633,333 square miles. So you're going to repeat the same activity with Greenland, Africa, India, and Scandinavia. Estimate their areas using the Peters projection map. Compare that to the actual area that Google gave you, take the difference, and see how well did you do this time. What are the differences between the Mercator map and the Peters projection map? Which do you feel is giving you a more accurate estimate on the area? Okay, so you should now pause the video and complete problem 3 if you haven't already done so, and then come on back. Okay, so now we're ready for a little bit of follow-up and discussion. So creating maps is a mathematical process. Every map, which is a 2-dimensional object, of our world, which is a 3-dimensional object, distorts reality in some way. Think, for example, about peeling an orange. If you take the peel off of that orange and try to flatten it down to a 2D, there's going to be some distortion there. And so the point of this activity was to compare the distortions in the Mercator projection map and the Peters projection map. Now the Mercator map was created in 1569 in Germany during the rise of European colonial expansion. And we'll see that that's important to remember when looking at this map. And the Mercator map is especially popular in schools. It's kind of the standard classroom map. But let's compare it. Here was that standard classroom map, the Mercator map. Look, for instance, at Greenland and Alaska on this map compared to our Peters projection map. It's quite a difference. Similarly, let's go back. Here is our Mercator map. Look at the continent of Africa on the Mercator map versus the Peters projection map. It's quite a difference. And hopefully you found that as well when you were analyzing these two maps and estimating areas. Now, the Mercator map is what's known as a conformal map projection, and this means that it shows shapes pretty much the way they appear on the globe. The map maker's dilemma is that you cannot show both shape and size accurately. If you want a true shape for the land masses, you'll necessarily sacrifice proportionality, meaning the relative sizes will be distorted. So in summary, that Mercator map is really good at representing shapes, but really bad at representing sizes. Now, this made sense. Remember, we said it was made during the rise of colonization, right? So those explorers, it was important for those explorers to have a good representation of shape. And that's why the creator of the Mercator map made that choice. But how does this affect us now? How is this an issue of social justice? The Earth is round, and the challenge of any world map is to represent a round Earth on a flat surface. There are literally thousands of map projections. Each has certain strengths and corresponding weaknesses, and choosing among them is an exercise in values clarification. You have to decide what's important to you. Let's see if I can show you what I mean. Let's find the equator on the Mercator map and mathematically describe the effect on the viewer that the placement of the equator has. So here's our Mercator map. Look where the equator is located. It's not in the middle of the map, it's been pushed downward. Well, recall that the Mercator map was developed in 1569 in Germany. And so Germany is near the center of the map, which made sense from the perspective of European expansionism. However, the only way to make Germany, which is actually 52 degrees north, the center is to push the equator approximately 2/3 of the way down the map. What happens mathematically then is that this compresses the southern hemisphere and enlarges the northern hemisphere. Now, how does moving the equator down in the Mercator map affect how we see the north as opposed to how we see the south? Keep in mind the north is mainly North America, Europe, and the south is mainly Africa, Asia, Central and South America. Who lives mainly in the north versus who lives mainly in the south in terms of race? And being able to see those sizes more accurately, would that change the importance that we place on these different locations? Here's another example. Let's find the international date line. I'll highlight it for us here. Why isn't it in the middle of the map? Again, because what's in the middle of the map is Europe and specifically Germany. Now, there are other options for maps. Here is one that decides to take our globe and make the map look more global in its depiction. Here's a map I really like called a population map. So the size of the region is dependent upon the population of that region. The bigger the country, the more people who live there. So for example, we get a snapshot of where humans lived and where they will be living. So here are 3 of the snapshots of human population located by continent on a timeline of human history, comparing 100,000 BC to AD 1650 to our prediction for AD 2150. Notice which regions are large and which regions are growing, depending on how population is changing in the world. Another example, who says the North must be on top? If we tend to think that things that are bigger are more important, if we tend to think that things that are on top are more important, then maybe we need to flip our map upside down to change the way that we view the world. I encourage you to take a few minutes and reward yourself with a pop culture reference. This idea of the Mercator versus the Peters projection map came up in an episode of the popular television show The West Wing a few years ago. So I encourage you to watch that clip to see it in action. And then here are some discussion questions for you to consider. Which of the two maps are you more used to, the Mercator or the Peters projection? Which map do you feel is more accurate and why? Remember, maps should accurately represent directions, longitude, latitude, and sizes. How does moving the equator down in the Mercator map affect how we see the North as opposed to how we see the South? And again, who lives mainly in the North versus who lives mainly in the South in terms of race? After doing this activity, which map do you prefer and why? Knowing that we were all raised on the Mercator map, how does that make you feel? Thanks for your attention during this lesson. I look forward to hearing your thoughts about this subject. See you in class, guys. Bye.